So guys, now that we are done with the theory of thermodynamics and thermochemistry, it's time for us to take a set of problems. It's time for the first question, which is: a fixed mass m of a gas is subjected to transformation of states from K to L to M to N and back to K as shown. Now, your job is to choose the correct sequence of operations that enable this transformation of states. Now, Sandeep is going to help us with solving the problem. Sandeep?
So fine. See, while solving any thermodynamics problems, the first thing you need to do is that, check for the key aspects or the key points that they have mentioned in the question.
Right.
See, in this question, they mentioned that it is a fixed mass M. Fixed mass in the sense it's a closed system.
Correct.
Right. So, there is no mass transfer.
Right.
Only heat transfer. Right. And in the question they have mentioned that it is a gas.
Yeah.
In the system we have gas, right?
Yeah.
So for gas we can use the equation PV equal to nRT.
Exactly.
If it is an ideal gas.
Yeah.
In real case we can use PV equal to ZRT.
But as far as J is concerned, we'll
we'll
deal with ideal gases.
Yes,
yeah.
exactly right. So fine. And they asked us to find whether in each system process either it is heating or cooling, etc.
Right.
Right. Now let us label this process 1, 2, 3 and 4.
Neat.
Right. See, in process 1, K to L. See, in this process pressure is constant, but the volume is increasing.
Yeah.
So in process 1, product PV it will increase.
Yeah. P being constant, V increasing with time. Yeah.
Yes. Right. Since pressure is constant, it is isobaric process, but volume is increasing.
Yeah.
Product PV is increasing.
Yeah.
In the sense PV equal to nRT, right? So temperature will increase.
Yeah. Because
In
the
the
whole product nRT is increasing.
Exactly.
And N and R are constant.
Exactly. So since temperature is increasing, it is heating.
Correct.
Right. Similarly, in process 2, L to M, there volume is constant. Look here. Volume is constant,
Correct.
but pressure is decreasing.
Mm-hmm.
It is an isochoric process. PV is decreasing. Right.
G.
So temperature is decreasing. So this is cooling.
Right.
Similarly, when we see process 3 and 4, in these cases also, in process 3, pressure is constant, volume is decreasing.
Yeah. So isobaric again.
Isobaric again. So product PV it is decreasing or increasing?
Decreasing.
Decreasing.
P
Right.
being constant, V coming down.
Yes.
Yeah.
PV is decreasing, right? So temperature is decreasing.
Correct.
Again it is cooling. And in process 4, pressure is increasing and
Yeah.
volume is constant, right?
Yeah.
Volume is constant, pressure is increasing here to here.
So isochoric.
Isochoric process, and temperature is increasing, right? Since product PV is increasing,
Correct.
so it is heating.
So the correct option would be
Heating, cooling, cooling, then heating. Option C. See, the
Correct.
main things you need to learn in this question is that, first try to extract information from the question. As
Right.
we did in this question, fixed mass M, so closed system, gas, in the sense we can use PV equal to
Exactly.
nRT, and how to extract information from the graph that they gave.
basically as much information as you can gather.
Exactly. So use this information and try to solve other problems.
Correct. So let's move on to the next question, guys. So people, we learned an important information in the last question. Always look for as much information as you can gather. Now let's see if you can do the same with this question. 2 moles of ideal gas undergoes isothermal reversible expansion from 2 liters to 8 liters at 300 Kelvin. the enthalpy change of gas is, Sandeep?
So fine. The first step while solving any question will be to extract information, right?
Correct.
So let's see the question again. They gave 2 moles of an ideal gas, right? So 2 moles n equal to 2.
Correct.
Then they gave it as an ideal gas. Again the gas laws are valid, right? So we can use PV equal to nRT here, right? And in the next part they gave it as isothermal reversible expansion.
Correct.
So what does isothermal say?
The temperature doesn't change.
Yes, temperature is constant,
Correct.
right? In the sense we know that internal energy, it is function of only temperature, right? For
Yeah.
gases. So change in internal energy will be
0.
0 here, exactly. Fine. And what else did they give? So it is expanding, right? From 2 liters to 8 liters
Yeah.
at 300 Kelvin, which is constant temperature, right? So they asked us to find enthalpy change.
Yeah.
What do we know about enthalpy? Relation between enthalpy and internal energy or something.
It's internal energy plus work done,
Exactly.
U plus
Work-
PV.
Work done equal to PV.
Yeah.
So change in enthalpy will be delta H equal to delta U plus delta of PV.
PV.
Right.
Correct.
So, but in this process, since it is a gas, we can replace PV by nRT, right?
Right.
So it will be delta of nRT.
Yeah.
But it is an isothermal process, right? So temperature is constant. So we can apply this change only for number of moles.
Correct. R being a constant. Yes.
Exactly. It is delta N into RT, right? So for this, H equal to delta U plus delta N RT,
Correct.
right? So delta U is 0 since it is isothermal process.
Yeah.
And delta N RT, since N equal to 2 moles, it is fixed,
Yeah.
constant, right?
Same throughout. Yeah.
So delta N RT is 0 again. So change in enthalpy is 0.
Oh, this seems like an interesting solution.
Exactly. See, one thing here is that they gave information about volume expansion here, 2 liters to 8 liters, and they gave temperature at 300 Kelvin.
Right.
Are we using it here? No, right?
Nowhere.
So these all are extra information they gave us to confuse us, right? So just don't confuse because of the extra information that they gave.
Right.
See, use whatever information is needed for you. Fine.
Okay. Again, that makes sense. Do not forget the basics. Let's move on to the next question. Guys, let's move on to the third problem. You are given the bond dissociation enthalpies of gaseous hydrogen, chlorine, and hydrochloride, and those are 435 kilojoules per mole, 243 kilojoules per mole, 431 kilojoules per mole, respectively. Calculate the enthalpy of formation of hydrogen chloride gas. Sandeep?
Fine. Before solving this question, let us revise a basic concept in thermochemistry.
Okay.
Hess law. Hess law states us that total enthalpy change taking place during a reaction depends on the initial and final states, and that is independent of the path. So
Okay, but
we had already learned about state function, right?
exactly.
Enthalpy is a state function.
Yeah.
So Hess law also states the same thing.
Okay.
Fine. Suppose that we have solid carbon and we are burning in presence of oxygen.
Yeah.
We get carbon monoxide gas. Suppose that enthalpy in this reaction is delta H1,
Yeah.
and in the second reaction carbon dioxide again reacts with half of oxygen to give us carbon dioxide gas,
Correct.
right? Let us suppose that enthalpy in this reaction is delta H2.
Okay.
And combining these two reactions, we get that carbon solid plus oxygen gives us CO2 gas, right? since Hess law states us that the final product it is independent of the part that is reached, right?
Correct.
So enthalpy of this reaction, it will be equal to delta H1 plus delta H2. Right. Now see, heat of reaction, it is a difference between sum of enthalpies of products and that of enthalpies of reactants.
Yeah, that we covered in the theory. Yeah.
Yes. One more point is that Hess law, it is generally used when determination of enthalpies of formation of those compounds which cannot be directly prepared from the elements. So in that cases Hess law is used. Suppose that, see, in the example that we considered, heat of formation of carbon dioxide.
Yeah.
So carbon dioxide can be directly formed from solid carbon and oxygen, right?
Correct.
There will be some compounds which cannot be directly formed from the constituent elements.
Yeah.
So in that cases we can use Hess law and we can find heat of formation of that compound.
Okay.
Right. Coming to the question, they gave that bond dissociation enthalpies of gaseous hydrogen, chlorine and HCl. Right.
Yeah.
Now coming to this, see, first let us see what is bond dissociation enthalpy. Suppose that we have a molecule XY. Dissociation, in the sense we are breaking that bond, so we need to supply some energy to break that bond, right?
Correct.
So that is called as bond dissociation enthalpy. Right. So they gave that see, hydrogen gas. So when we are breaking hydrogen molecule into two atoms, so energy required is delta H1, it is equal to 435 kilojoules.
Correct.
And
Per mole. Yeah.
per mole, exactly. And similarly for chlorine, it is 243 kilojoules per mole.
Correct.
For HCl, it is delta H3, it is equal to 431 kilojoules per mole.
Correct.
Right. See, Hess law states us that heat of reaction, it is difference between sum of enthalpies of products minus that of reactants, right?
Correct.
But in this we are using bond dissociation enthalpies. We are supplying energy to break these bonds, right? So there is only one exception, that in this case we'll make reactants minus products.
And why is that?
Since we are supplying heat here.
Okay. So in case of enthalpies.
Okay. So while we are using bond dissociation enthalpies, always do heat of reactants minus heat of products. Remember this thing. Fine, right? So now they asked us to find heat of formation of HCl. Right. What is heat of formation? Heat required for formation of 1 mole of HCl. Right. So what is the reaction? Half of H2 plus half of Cl2, it gives us 1 mole of HCl, right? These are the constituent elements, and we are finally getting 1 mole, right? So heat generated in this reaction, it is heat of formation of HCl.
Right.
Fine. So from Hess law we know that it is reactants minus products heat.
Yeah.
Bond dissociation enthalpies. Right. So 435 into 1 by 2.
Yeah.
Since 435 kilojoules per mole.
Yeah.
And
for
we
half
want
a mole
for
you
half
need.
mole. Right. And plus for chlorine in the same way.
Yeah.
243 into half. Minus 431. Since this is only 1 mole. Right.
Correct.
Here we'll get it is minus 92 kilojoules. So heat of formation is 92 kilojoules.
Okay.
Right. So
So this
we
much
can-
amount of heat would be released when
exactly
HCl
when 1
forms.
mole of HCl is formed.
Okay.
Without knowing Hess law also we can do this problem directly.
Okay.
Let us see that. See, they gave us bond dissociation enthalpies of hydrogen, chlorine and HCl, right? H2, Cl2 and HCl.
Correct.
Right? Use some basic algebra. See, we want to find heat of formation of HCl. In the sense, heat involved in this reaction.
Correct.
Right? So, use algebra for equation 1, 2, 3 and get this one.
How do you do that?
Add equation 1 plus 2, divide it by 2, subtract it from the third one.
Then you get this equation.
Then we'll get this equation.
Okay.
Right. So, in the same way, heat of formation of HCl will be delta H1 plus delta H2 by 2 minus delta H3.
So basically you can apply simple algebra.
Simple algebra, that's what. And that is equal to 92 kilojoules per mole.
Comes out to be the same.
Exactly.
Okay.
So, whenever you want to find heat of formation or heat of combustion, do simple algebra with the given equations and try to find out whatever they are asking.
And the same algebraic operations work in this case.
Exactly.
Okay. So let's move on to the next question, guys. Let's have a look at the fourth question now. A piston filled with 0.04 mole of an ideal gas expands reversibly from 50 milliliters to 375 milliliters at a constant temperature of 37 degrees centigrade. As it does, so it absorbs 208 joules of heat. The values of Q, which is the heat absorbed or released, and the work done for the process will be... Sandeep?
Coming to the solution of this problem, first let us see what all is given in the question. See, a piston filled with 0.04 moles of gas, ideal gas, right? And it expands reversibly.
Correct.
From 50 ml to 375 ml.
Yeah.
Right? At constant temperature, 37 degrees centigrade. So they gave that system is at constant temperature. What does it imply?
That it's an isothermal process.
Exactly.
And the internal energy doesn't change.
Exactly. So in an isothermal process, since temperature is constant, change in internal energy will be zero. What did they ask us to find? Values of Q and W. So from first law of thermodynamics, what do we know? Delta Q, it is equal to delta U plus delta W, right?
Correct.
This is conservation of energy.
Yeah.
Fine. But delta U is 0 since it is isothermal process.
Naturally, yeah.
So delta Q, it is equal to delta W. In the sense, whatever heat that you are supplying to the system, that heat is utilized for doing work.
Correct.
Right? But in the question they gave that it is absorbing 208 joules of heat.
Yeah.
Right? It is absorbing.
Yeah.
So heat is into the system.
Yeah.
So what will be the sign?
Positive.
Heat is into the system. Exactly. So Q equal to plus 208 joules.
Yeah.
Right? Work done.
Negative of that.
Magnitude will be 208 joules. But
Correct.
what will be sign convention?
Negative, since the work's done by the system.
By the system, right? So Q equal to 208 joules and work equal to minus 208 joules. Here 208 joules we are supplying into the system, and 208 joules of work it is done by the system.
Being used as it is. Yeah.
Exactly. Here in question they gave a lot of extra information. They gave about number of moles of ideal gas and 50 ml to 375 ml, and they gave other information also, but we didn't use anything, right? Just
even
use
the
a basic
natural log of
equation.
5 they gave.
Exactly. Be with your basics and use whatever you know here. That's it.
Okay guys, let's move on to the next question now.